طيب okay. Can you hear me? طيب, we are going to cover module 14 and 15 today. Now, what module 14 talking about? The transport layer and the protocols of the transport layer. For module 15, it's talking about the application layer. You will see it's very simple and even fast to be covered. Now, what's the main rules of the transport layer? Transport layer is responsible for a logical communication between applications running on different hosts. So how we will use the email system, for example, the DNS, VoIP application, FTP, SMTP, it's the responsibility of the transport layer. So it's considered the link between the application layer and the layers below. If we looking at the TCP or the OSI, so the link between the application layer and the lower layers that are responsible for network transmission. Keep in your mind, transport layer will not has any knowledge about the host type, about the media used to transmit the data, the path that taken for the data, even the size of the network. In general, the transport layer will include two protocols, either TCP or UDP. So, transmission control protocol and user datagram protocol are the protocols operates at the transport layer. Now, what are the main responsibilities? For the transport layer, we have the following main responsibilities. First point, tracking individual conversation. So what do we mean, or what do we mean by the conversation? Now, any data set following between a sender, let us call it a source, and a destination application, it's called conversation. And it should be tracked. It should be tracked separately. So it's the responsibility of the transport layer to maintain and track multiple conversation. Why multiple? As you see here, we use the email, we use the instance message, we use multiple web pages, online video chatting, stream video. So all of these considered as what? As an application. Each one of these applications will establish and has a conversation to exchange or to send what? Let us say a data set. So we need to track this data set. Number two, segmenting the data and reassembling the segments. Now, also transport layer will be responsible for dividing the application data into appropriate equally sized block. Now, depending on what? It's a segmenting process. Depending on the protocol that will be used, it can be called either segment or datagram. So when we call it segment, if we're using the TCP protocol, when it will be called datagram, if it's a UDP, a protocol. Next responsibility is add a header information. Transport layer will add header information as well, containing a binary fields. These fields will be used to enable a different transport layer protocols to perform different functions in managing the data communication between the source and the receiver or the destination. Next responsibility, identify the application. Identify, separate, and manage multiple conversations. Keep it in your mind here. In order to pass the data stream by using the proper application from the source to the destination. How the target application is identified. How the client will say, I need to communicate with the email server. I will use the instance message. I will connect the web server. So how we will identify the destination application? And please focus here. Usually, transport layer will identify the target application by using its port number. We will use a unique identifier or using an identifier. What's the identifier? We will use it to identify each application, the port number. For example, when we talk about the email, in order you need to retrieve an email, you will use the port 110. HTML, for example, we are going to use the port 80. Now, transport layer also uses segmentation and multiplexing to enable different communication conversations to be interleaved on the same network. As you see here, we have a client. The client has multiple or multiplexing conversation. We use multiple applications at the same time on the same network. How will it track each conversation? Uniquely, it will use a different port within the source and the destination. Now, as we have mentioned, we said that for the transport layer, we have two main protocols, TCP and UDP. If it's a TCP, we'll call the dataset a segment. If it's a UDP, we call it datagram. So when we talk about the IP does not specify how the delivery or the transportation of the packets take place. Now, transport layer protocol specify how to transfer the messages between hosts and responsible for managing reliability requirements of the conversation. So, IP does not specify how the delivery or the transportation will take place. It's the responsibility of what? Of the transport layer. And it will be managed, controlled by the transport layer. So for the transport layer, two protocols are includes, either TCP or UDP. What's the difference between them? One of them is connectionless, one of them is connection oriented, and this is what we will see in the coming parts. So first protocol is the TCP. TCP provide reliability and flow control. Reliability and flow control. So what does that mean? The TCP will maintain the state of the conversation and track information about that one. So the TCP will establish here a connection between the sender and the receiver. Before sending any data set, a connection will be established between the sender and the receiver. So because of this connection that will be created before or prior sending any data set, TCP is called connection-oriented protocol. And when we talk about the segmenting of data here, point number 2. Now TCP will divide the data into equally blocked size, called segments here. So what are the basic operations of the TCP protocol? Remember, it's reliable protocol. We will track the status of the data or the segments we have sent from the source to the destination. We'll monitor the acknowledgement. We'll resend any missing segments. Resend, so it's a reliable flow control connection. So the basic operation, number and track the data segment transmitted to a basic host from a specific application. How will number the segments? Sequence number. So dividing the data into set of segments, numbering the segments in order what? To be reordered correctly if it's received in the correct order, in incorrect order at the receiver. Acknowledge the received data. They will monitor. Any received data should be acknowledged and the sender should be received. In case we have a TCP connection here, retransmit any unacknowledged data. After certain amount of time, sequence the data that might arrive in wrong order, so it doesn't matter at all. Even if the receiver received the data on the incorrect order, it can be reordered correctly. Finally, send the data at an efficient rate that is acceptable by the receiver. We are talking about here the window size, and we'll discuss it in the coming part of this meeting. So for example, here we have a file. The client would like to communicate, let me say, to the FTP server. Instead of sending a single set of data, the data will be divided into 6 segments, and we are going to send each segment separately to the server. Now, once the server received the segments, the server should acknowledge that segments received correctly. Otherwise, it will be resent one more time in case we are using a TCP connection and the acknowledgement was not received. Clear? Now, for the UDP is simpler transport layer protocol than the TCP. Simply, UDP does not provide reliability and the flow control. So the header fields will be fewer compared with the TCP, as we will see later on. And because the UDP do not have to manage the reliability and the flow control, it means that it's faster than the TCP segments. Now, what we call the data set at the UDP, we'll not call it a segment, we call it datagram here. So UDP faster than the TCP, but the UDP do not provide any reliability and the flow control. Even the UDP, do not track information sent, do not track or any received acknowledgement. So if the data lost, it will not be resent. If the data received in incorrect order, it cannot be reordered. So the data will be ordered according to the order it received with. So this is the main difference. So we can say that UDP is a stateless protocol, while the UDP is what? Connection-oriented protocol. Stateful protocol, not the stateless protocol. So UDP provide a basic function for delivering a datagram here, not a segment, between the appropriate application with a very little overhead and data checking. So UDP is connectionless, a protocol. UDP also called best effort delivery protocol. Why? Lower overhead, faster than the TCP, because there is no acknowledgement that the data is received at the destination. Even any missed data, the sender will not know, will not get any details. The sender will not handle it by resending the missing datagrams. واضح الفرق بينهم؟ يعني التي سي بي will track my data, will handle any missing data. For the UDP, no. واضح؟ طيب, now also the UDP is used by a request and reply application where the data is minimal and retransmission can be done quickly. Give us an example about this. What do you mean by request and reply application? UDP can be used by request and reply application where the data is very small and the retransmission process can be done quickly. For example, we have a DNS server, domain name service. So the domain name service will use the UDP for a type of a transmission between what? Transaction between the client and the DNS server. So the client will request an IPv4 or IPv6 address from the domain name, from a known domain name. Kindly, what's the IP of this domain name? So this request will be sent to the DNS server. Now the client will wait. If the client did not receive any response for that request for a predefined amount of time, simply the client will do what? Will resend the request one more time. So we are talking about a known service. We are talking about a known service here. Request and reply application. We know where we will send the request, so the UDP can be used here. Now, another case or another applications where we prefer the UDP than the TCP, if we cannot tolerate with the data loss, which means some application can tolerate to some data loss, but the delay is not acceptable. For example, the VoIP application. So it's better for this kind of application to use the UDP. It will be the better selection than the TCP. Why? Because it requires less overhead. So for the application or the real-time application like VoIP, acknowledgement and retransmission will slow down the connection or the conversation. So slow down, delay, it's not acceptable. Now, for some other application, for example, the data should arrive and the process in a proper sequence. We need to track the sequence. It should be processed in a clear order. So in this case, we need a connection-oriented protocol. So TCP is the transport protocol, can be used in this case. Example about an application needs to process the data in a specific sequence. For example, the web browser, database servers, email servers. So the data should be sent and received between the sender and the receiver in a specific order. Because of this, we use the segmenting and the sequences of the segments. Now, real-time videos and voice usually will use the UDP. Applications that require the data to be processed and received in a specific order, TCP. We can accept in somehow the data loss, but the delay is not acceptable at all, UDP. So, example about a UDP application, we talk about the VoIP, voice conversation, DNS, domain name service, this one a request and reply application. So, main features of the UDP, fast, lower overhead, does not require an acknowledgement from the receiver, does not resend the lost data, delivers the data as it arrives. The data will be reassembled on the same order they arrived at. This is the last point. Now, while the TCP as a comparison, for example, when we're talking about the email, so simple mail transfer protocol or internet message access protocol, for example, the HTTP or the HTTPS, reliable, acknowledged data, resend any data lost. How we will resend it? We will not receive an acknowledgement, so it will be resent. Delivers the data in a sequenced order. Even if the data arrived in different order, it will be reordered one more time at the receiver side. Any question? Now for the TCP, what are the main features? Remember, TCP will create a session, a conversation prior sending any data. So establishes a session. TCP is a connection-oriented protocol that negotiates and establishes a permanent connection or a permanent session between the source application and the destination before sending any data traffic. So this is the first feature. Second one, ensure reliable delivery. So it's possible here for the segment to become corrupted or lost in somehow, as it's transmitted over the network by using different routing paths from the source to the destination, for example. So to ensure that each segment is sent by the source arrive to the destination, it's the responsibility of the TCP. So TCP will ensure that every data segment sent, it's received by the destination. How? They will wait and they track an acknowledgement. Any data segment not acknowledged means it corrupted or lost in somehow. It will be resent, as we'll see later on. Provide the same order delivery. Now the network can use a multiple routers with different paths, so the data might be arrived in the wrong order. By using the sequencing, it can be reordered on the correct order. The flow control. So network hosts have a limited resources. For example, when the TCP is aware that these resources are overtaxed, خلينا نقول يعني منهكة, it can request that the sending application reduce the data flow. So the receiver is totally full. The receiver cannot process the received data. The memory is overloaded. So the sender here can monitor the status of the receiver and reduce the amount of data sent before the sender will expect an acknowledgement. We'll talk about this when we talk about the flow control and the window size. So we can reduce the amount of data rate from the source to the destination. Now, as we have said, TCP is connection-oriented protocol. TCP is a stateful protocol, which means that TCP will keep track the state of the communication of the session. So the TCP, to track the state of each session, TCP will record an information. Record which information it sent, which information acknowledged, and so on. So how the TCP will be a reliable flow control protocol? We need a set of fields recording information about the status of each data segments here. So usually TCP segments will add 20 bytes of overhead when encapsulate the application layer data. So TCP receives the application layer data. TCP adds 20 bytes or 160 bits as what? A TCP encapsulation process segment to the data received from the application. Now, As you see, we have many fields here. We have the source port, destination, sequence number, acknowledgement, and this number is the number of bits per field. So 16-bit source, 16 bits destination, 32 sequence number, 32 bits acknowledgement, header length 4 bits, reserved 6, control bits or the flag 6 bits, window size 16 bits, checksum 16, and urgent 16. Finally, optional from 0 to 32. So, source port simply, it will be used to identify the source application by the port number, the sender source application, because we said that we will identify the application uniquely by using an identifier. This identifier is the port number. Destination port also will be used to identify the destination application by the port number. So the source port for the client, for example, 1935, destination port is 80. So it's a web server here. Sequence number, 32 bits, as you said, used what for the data reassembly process. We have mentioned that if the data arrived in the wrong order, it can be reordered into a correct order by using some information. It's TCP. We'll use the sequence number. Acknowledgement number. This field used to indicate that the data that has been sent has been received and the next byte expected from the source, what is it? What is it? So please focus here. Usually the acknowledgement informing the source about the next expected byte number. The next expected byte. Just keep it in your mind. Header length or data offset indicates the length of the TCP segments. Reserved, it's reserved for any future use, 6 bits only. Now, control bit or a flag indicate the function of the TCP segment. What's the function of the TCP segment? It can be known by a number of bits. Inside the control bits called the flag. Window size used to indicate the number of bytes can be sent or can be accepted at one time. So what's the window size? The number of bits that can be sent before the receiver will send the acknowledgement. So how many bytes can be sent from the source to the destination before expecting or waiting an acknowledgement? La, it's not 16. This is the field size, ya Asma. The field size is 16 bits. La. So we can identify the size of bytes that can be sent before we expecting an acknowledgement by this field, but it's not 16 bit. تمام؟ يعني أنا ممكن أرسل 10,000 بايتس بعدين أنتظر الفيرست acknowledgement. لأن ممكن بعد أول 3000 بايتس تجيني acknowledgement. ما عندي مشكلة. ولكن كم الماكس يرسل بعدين لازم الاكنولجمنت تجيني، هذا اللي هو الويندو سايز. Clear? Checksum for the error detection or checking for sure. And finally, urgent means that used to indicate that if the content of the data is urgent. Now, all discussion and explanation about these fields already written in this table here. Now, what kind of application that use TCP? Now remember, if it's a real-time application, delay is not acceptable, UDP usually. We can deal with the delay, but the order is very important, TCP. We need to track the data, TCP. Reliable with the flow control, TCP. So TCP handles all the tasks associated with dividing the data stream into segments, providing reliability, controlling data flow, and reordering the segments. So usually, hypertext transfer protocol, HTTP, file transfer protocol, simple mail transfer protocol, secure shell for the secure connection protocol, using or starting by establishing what? A TCP session between the source and the destination. Now, UDP, as we said, it's the best effort transport protocol. UDP is light transport protocol that offer the same data segmentation and reassembly as the TCP, but similar to the process or the function provided by the TCP, except of what? Without reliability and without the flow control. So main features of the UDP, data is reconstructed in the order it is received at. Can you give me just 2 minutes? 2 minutes, please. دقيقتين لو سمحتوا. Type, sorry. So data will be reconstructed at the UDP or by using the UDP in the same order it received at. Any data segment lost, actually we should say any datagram here lost will not resend. There is no session establishment prior the transmission. The sending is not informed about the resource availability. Even we do not know anything about the receiver. So UDP is what? Best effort, lower overhead. As you see, we have only 4 data fields: source port, destination, length, checksum, 8 bytes within the same tasks, same features for each field as what the TCP. So the source port used to identify the source application by the port number. Destination port identify the destination application by the port number as well. Length is the length of the UDP datagram header here. Checksum, error checking for datagram header and data. Now, what are the kind of the application that can be used or that use the UDP, protocol? Dynamic host configuration protocol. This one is what? Request application. It's a request and reply application. DNS, domain name service. Simple network management protocol, trivial file transfer protocol, voice over IP address, video conferencing, what else? SMTP, Bob. No, sorry. The email is not, no. The email is TCP, not UDP. Sorry. Email is TCP, not UDP. So, live video and multimedia application. This application can tolerate to some data loss, but required a small or little with no delay. Example, VoIP and live streaming videos. Simple request and reply applications. This application with a simple transaction where the host will send a request and may or may not receive a reply. So I send a request to the DNS, or the host send a request to the DHCP. Within a predefined amount of time, no response sent back from the server. Simply what we will do, we'll resend the request one more time. Now, applications that handle reliability themselves, which means it's a unidirectional communication, one direction application. We're talking about the TFTP, where a flow control, error detection, acknowledgement, and error recovery is not required or can be handled by the application, we can use the UDP, or it will use the UDP in this case. So we're talking about simple network management protocol or trivial file transfer protocol. Any question? Now, remember, we have said port number will be used to identify the source or the destination application by the port number. So TCP and UDP transport layer protocol use the port numbers to manage multiple simultaneous conversation. What does that mean? My client or my PC can open a web browser, checking the email, streaming or watching any data file. So we can use a multiple application. Let me see. At the same time, in parallel, how we will distinguish between them? By using a different port number. So the source port number here, usually source port number is associated or linked with the what? With the originating application on the local host. The client, in this case, the one who sent the request, originate the application, where the destination port number usually associated with the destination application on the remote host. Keep in your mind port number. So for example, the source here, we can say we have a host. When the host initiates the web page request, send the request for a web page to the web server. So the source port number here will be generated dynamically by the host to identify uniquely that conversation. So any request generated by the host will be uniquely identified by using a different dynamic identifier number, or by using a different what? Port number. Because of this, we can have multiple conversations at the same time. One more time, client will request a web. The client will generate a random number to uniquely identify this request. This number actually, it's what? a port number for this conversation. We have a different application, different port number, another application, another unique port number, and so on. So what's the socket pairs? The source and destination ports are replaced within the segment. As you see here, for example, we have a client. The client will connect the server for FTP. Here, we are using the FTP. Now, for the second example, the client also will initiate a request to the web server. So, the source port is the dynamic, unique ID number generated at the client. The destination port 21, it's a predefined, well-known port. We know, as you will see later, that 21 ports FTP. Okay, now, what's the socket? What's the socket? The combination of the source IP address and the source port number, or the destination IP address and the destination port number, is called a socket. So what's the socket for the client? What's the source IP address of the client? 192.168.1.5. What's the source port number? 1305. So the socket here, it's the IP colon the source port number. Now the destination socket, the IP of the destination device 192.168.1.7, followed by colon and the port number. What's the port number here? 21. What's the port number? What's the socket number here? It will be end by 80. Now what's the source for the web request? As you see here, the client used totally same client, two different source port. Every conversation will assign a uniquely different identifier, a port number. So we have used here 1305, 1099, 80 is a well-known port number. For sure, it will be the destination as a web. Once we see 80, we know it's a web request, HTTP protocol, and so on. So sockets will enable multiple processes running on the client. In order to distinguish themselves from each other and multiple connection to the server, to a server process to be distinguished from each other. So we have two conversations running at the same time to the different or the same server by using totally two different port number from the source. So what's the socket number of the client as a source? IP address and port number. What's the socket number of the FTP server as a destination? The IP address and the port number 21. Now what's the source IP address socket number for the web request at the client or the source? The IP address and the port number 1099. What's the destination socket number or the socket pair? IP address of the destination server and the port number. Clear هذا واضح؟ طيب, as you see, port numbers can be divided into set of a group. First group, well-known ports from 0 to 1023. Simply these port numbers are reserved for a common or popular services, 21 FTP, 80 HTTP, 53 DNS, and so on. So, from 0 to 1023, port numbers reserved for a common or popular application or services such as the web, email, remote access, for example. Defined well-known protocol port, from a common server application enable the clients to easily identify the associated service required. So this is the main benefit of the well-known ports. We have the second group registered port from 1024 till 4951. These ports are assigned by IANA. IANA, which stands for, I forget it, International Agency for National Numbering or Addressing Numbering. It's to assign or allocate the public IPs actually. Okay, Internet Assigned Numbers Authority. Okay, now these port numbers are assigned by IANA to requesting entity to use with a specific process or application, which means what? We can reserve simply or register an application to specific what? Service or application. We will register the application. Because of this is called registered application. So these processes are primarily individual application that the user has chosen to install, usually for a different application user installed, rather than the common well-known application would receive a known port number. Example, Cisco has registered the port 1812 for the radius for the remote authentication dial-in user services, which a server used for the authentication, authorization, and accounting services to manage the user. So we have registered this port for this kind of server in order to implement the authentication process. Finally, private or dynamic ports. As you see, the range is very large here. These ports also called ephemeral ports. سريعة الزوال خلينا نقول. So the client's operating system usually assigns the ports dynamically when the connection to a service is initiated. The dynamic port is then used to identify the client application during the communication. So mainly the random number will be generated at the client to identify a unique port for each conversation will be or should be within this range. Now let us have a look to an example about some well-known port numbers. As you see, we have a 20 and 21 TCP protocol. The protocol that will be used at TCP, usually used for transfer protocol, FTP for the data, and FTP to establish the session before the control. Port 22 TCP secure shell. 23 telnet, also it's a TCP. 25 TCP port, simple mail transfer protocol. Now 53, it's a UDP or TCP. How? Now, usually between the client and the DNS server, it will be used, or we will use the UDP when any client sends a request to the server. But communication between two DNS servers always using TCP. So between a client and server UDP, between two DNS servers, always we are going to implement and use UDP connection or UDP protocol. Sorry. 67 DHCP, 68 DHCP for the client, 69 trivial FTP, 101 Bob protocol. For the email, it's a TCP. 143 Internet Message Access Protocol. 161, for example, Simple Network Management Protocol. 443 HTTPS. So what does that mean? We cannot use any other port for this well-known applications. FTP should be 21 and 20 at the server. When we say simple mail transfer protocol to send an email, it should be the port 80 to be used, 25, sorry, to be used at the server, and so on. You should memorize the most common application ports, by the way. Now, what's the net state? Sometimes, simply we need to know which active TCP connection are open and running on the network host. So we can use the net state, as you see, in order to provide the list or list the protocols in use. So it will list the protocols, followed by the local address, then the port number, local address, port number, local address, port number. So this is the socket pair at the client. IP address, different port number, followed by the foreign address and the port number as well. I'm talking about this column, and finally the connection state. So as you see, we have applied or performed net state commands, different ports using the TCP from different addresses or servers. And what about the TCP connection? Status established, 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 established. Now, we are going to talk about the TCP communication process, the establishment, the handshake process in other way. Now, each application process running on the server is configured to use the port number. Any application run at the server side will be configured to use a different port. We cannot have two applications at the server running and using the same port number. So as you see here, for example, for the web services, for the HTTP protocol, the port number at the server will be 80. For the email transfer protocol, the port number is 25. So server cannot have two services assigned to the same port number within the same transport services. Number two, an active server application assigned to a specific port is considered open, which means the transport layer accepts and the process segments address to that port. So the client will send a request to an active port requesting any web page. So HTTP request will be sent to port number 8. Now, who's the source now? For the server, the source is the IP of a client 1 and the port number 49152. Now, what's the destination port for the client? 80. Now, when the server responds back to the client, the source port will be 80, which is the well-known port number at the server, and the destination port is what? The auto-generated identifier at the client, 49152. Same here, a different client requests the FTP, the SMTP, sorry. So the source is 25, the destination here. At the client side, the destination port is 25, the source port is the sender, unique identifier 51152. Now, when the server will send back a response, SMTP response to the client, source port 25, destination port is the destination client, unique identifier 51152. So any incoming client request addressed to the correct socket is acceptable and the data is passed to the server application. So any incoming request comes to the server at the correct port will be accepted. Now, keep in your mind, TCP session should be established between the client and the server before the SMTP start its command line exchange operation. And we'll talk about it now, after a few slides. So this is the TCP initiating. It's called the three-way handshake. And it's usually used to validate that the destination host is available to communicate. So what we have here, we have host A established a TCP connection session with host B. Once the session is established correctly, it means that host A validate that host B is alive. Now, any TCP session will established by using the following three steps. Step 1, 2, 3. Because we have three steps, we call it a three-way handshake process. Any different, yes, no, TCP session is no. Now, any different application will use a different source port, yes. We cannot use the same source port. نعم حسب الابليكيشن يا اسماء. Email we need to send 25. Email we need to receive 1110. We need to receive an email, but we will keep it at the server. We will get a copy 143. Now web 80. Same port number used for different services? No, no. No, especially this. Port number reserved for the FTP. Port number reserved for the FTP. Will not use it for different service. No way. No way. خلاص 25 email 110 email 80 HTTP. Will never change the default service. So how TCP is established? Step 1, the client initiating or the initiating client request a server communication session with a server. So the client will send to the server synchronized request. So the sequence number is 100, clear to send synchronization. Hello, it's like the client will send to the server hello message. Now step 2, the server will acknowledge the client to the server communication session and request a server to the client communication session. Hello? Yes, we can create a session with me, for example. So, client send or establish the request. The server will send an acknowledgement and send what? Server to the client communication session request. So as you see, we said the acknowledgement always specify the next expected bytes. So 100, we are expecting 101 now. So the client will send an acknowledgement synchronization. Now the server sent the acknowledgement and the request. Step 3, the initiating client acknowledged the server to the client session. It will send an acknowledgement for this request. Sequence number 101. Sorry, the acknowledgement will acknowledge what? The request 300 here. The sequencing 300. Server to the client communication request. Once the last request acknowledged by the client, now we have a permanent TCP session established between the client and the server. What we call this a three handshake or way handshake process. Send a request, send an acknowledgement and request, acknowledge the server request. TCP session, any TCP session, any TCP protocol should start with these three-way handshake establishment process. Any protocol should be terminated by using the following 4 steps. So in order to terminate a session now, step 1, when the client has no more data to send in the stream, the client will send a finalize flag by using the 6 bits or the control bits fields on the TCP segments. So client will send finalize flag to the server. The server will acknowledge, receives the finalize. The server will send the finalize as well to the client. The client will send that the acknowledgement receives, the finalized receives, so we'll send an acknowledgement, acknowledgement receives, the connection is terminated, or the TCP session, sorry, is terminated. So step 2, the server will send an acknowledgement, acknowledge the receipts of the finalize to terminate the session from the client to the server. Step 3, the server will send fine or finalize a flag to the client to terminate the server to the client session. Client will respond with an acknowledgement to the last request. Server to the client session. Acknowledge the finalize from the server. Once it's received, session terminated between the client and the server for the TCP connection. How many steps? 4-way handshake. Let me say 4 steps. Establishment, how many? Step 3. واضح؟ Now, what are the function of the TCP session, the 3-way handshake? What's the main function? Point number 1, it establishes that the destination device is present on the network. It verifies that the destination device has an active service and accepting the request on the destination port number and the initiating client intended to use. It informs the destination device that the source client intended to establish a communication session on that port number. So we verify that the port or that the service is active, the communication is active, and will establish a connection to that port number. So after the communication completed, the session will be closed and the connection will be terminated. So the connection and the session mechanism enable the TCP reliability function. How we will terminate the connection? By using the 4 steps. Send fine, then send acknowledgement, send finalize, send acknowledgement. Now, what's the control bit here? 6 bits of control bit fields, or can be called as a flag. So simply, it's a control bits that can be set either on or off. Now we can use different flag values for different segment type. For example, we can use urgent, which means a field is significant here. Acknowledgement segment. So how we will know that this one is an acknowledgement? By using the control field, the flag bit, or the flag field. Acknowledgement flag used in the connection establishment and the session termination. Push function. Reset the connection when an error or timeout occurs. Synchronize the sequence number used in the connection establishment, as you see here. We use a synchronize and acknowledgement actually. And FIN, or finalize no more data from the sender, and used in the session termination. So different values for the bit control to identify different segments with different functions by using the control bit flags. Simply it will be set on or off, and then we will add any flag number. Now, we have mentioned that TCP is reliable flow control TCP protocol, or transport protocol. So TCP help or can help to maintain the flow of packets so that the device do not become overloaded. In some cases, the data segments will not arrive to the destination, or it will be arrived on the wrong order. So all data must be received, and the data in these segments must be reassembled in the original order. Sequencing numbers will be assigned in the header of each packet to achieve this goal. For example, here, the source has sent the segments from segment 1 to segment 6. At the receiver side, different paths used by the routers, so segments is not arrived in the correct order, as you see 1, 2, 6, 5, 4, 3. Now sequencing, or the sequence number here, will be used as the receiver to reorder the segments in the original order. So we'll reorder the incorrect ordering segments to the original one by using the sequence number. TCP is reliable here. So segment 1, 2, 3, 4, 5, 6. Now, also keep in your mind, during the session setup between the client and the server, for example, a special value will be set. It's called ISN, initial sequence number. Now, the initial sequence number representing the starting value of the bytes that are transmitted to the receiving application. So here, for example, the starting value is 1. But in reality, it will not be a sequence 1, 2, 3, 4. It will not be a 1. Only for clarification, we have assigned the ISN number, the initial sequence number, to 1. Now, one more time, what is this? It used to represent the starting value of the bytes that are transmitted to the receiving application. Now, as the data is transmitted, the sequence number will be incremented. The ISN will be incremented by the number of bytes that has been transmitted. So this data bytes tracking enables each segment to be uniquely identified and acknowledged by the starting byte numbers of each one. So any missing segments can be identified in this case, as you will see in the few coming bytes. So remember, indicating only the starting, one more time, the starting value of the bytes that are transmitted. Now, let us talk about the data loss and the retransmission process. Now, please focus here, okay? We have a connection session between the client and the server by using a TCP. So the sender A transmit all the segments from segment 1 till segment 10. Okay? Now, only all segments was received. Only segment number 3 and 4 was not received to the receiver device correctly. So, the acknowledgement always will indicate the expected coming segment, the new expected one. So sequence number and acknowledgement number will use together to confirm what the receipts of the bytes of the data contained in the transmission segment. Sequence number identify always the first byte of the data segment being transmitted. Now, acknowledgement number sent back to the source the next expected byte to be received, the next expected byte. So now B received segment 1 and 2 without any problem. Now 5, 6, 7, 8, 9, 10 also receives. Now B will send to A acknowledgement 3. What does acknowledgement 3 means? I have received segment 1 and 2 correctly. Now the next expected segment for me byte is 3. So what A will do? A simply will resend all the segments from a 3 to 10. So what happened here? Segments 5 to 10 what duplicated since 2 times. So this is one of the cases, one of the problems, let me say, within the TCP. So TCP will provide a method for managing these segments losses among these in a mechanism to retransmit the segments for unacknowledged data. So in this case, host A send the segments from 1 to 10 to host B. Now, all segments arrived without any problem except of segment 3 and 4. Now, simply host B will reply to the host A by sending what? An acknowledgement indicating the next segment expected to be received. Which one the next segment expected? Segment 3. So what the client will do here, host A simply will resend according to the acknowledgement the segments from a 3 to 10. Now, if all the resent segment is received successfully in the second time, what's the problem here? Segments 5 through 10 will be duplicates. Now, this will lead to what? To a delay problem inefficiencies problems. واضح ليش صار عندي duplicate؟ الآن always the acknowledgement indicating the next expected segment. So I have received 1 and 2 as B. Now I'm expecting 3. I will send the acknowledgement 3. I have received 3, 4, 5, 6. I will send an acknowledgement 7. So I'm expecting now the byte 7. I have received 7, 8, 9, 10. My acknowledgement will expecting what now? 11, and so on. Now, how we can handle this issue? How we can avoid the duplicate? Host operating system today typically employ an optional TCP feature called selective acknowledgement. So if we apply or using the selecting acknowledgement, we can avoid duplicating any data segments. So selective acknowledgement negotiated during the three-way handshake. Now, let us back to the same example. If both hosts support the selective acknowledgement, the receiver can explicitly acknowledge which segments were received, including any discontinuous segments. How? For example, we have host A transmit the segments from 1 through 10 to host B. Now 1, 2 receives correctly. 5, 6, 7, 8, 9, 10 receives correctly. Now what we have missed? 2 and 4. So in case the selective acknowledgement is applied, host B will acknowledge that I have received the segment 1 and 2. So host B sent to host A, I have received segments 1 and 2. But I'm expecting a 3. So acknowledgement 3. ACK 3. And host B will selectively acknowledge the segments from 5 through 10. So selective acknowledgement 5 to 10. So in this case, the host A will resend only segment 3 and 4. So we have resend the 3, 4. Now 5 through 10 selectively acknowledged. So 11, 12. Now the host acknowledged 13. So it means what? 3 received, 4 received, 11 received, 12 received. Now host A will send 13, 14, 15, and so on. So this is the selective acknowledgement. In this way, we will not duplicate the segments through 5 to 10. How? B acknowledged I have received 1 and 2 by sending acknowledgement to 3. B selectively acknowledged segments from 5 to 10. واضحة؟ عندكم أي سؤال؟ طيب now, finally, almost we have done. Let us talk about the flow control and the window size and the acknowledgement. Now TCP also provide a mechanism for flow control as following. Flow control is the amount of data that the destination can receive and process reliably. So flow control will help to maintain the reliability of the TCP transmission by adjusting the rate of the data flow between the source and the destination for the given session. So simply, now, TCP header will include now 16 bits. With 16 bits, the window size bits. Now the window size bits will be used to determine the number of bytes. The number of bytes that can be sent before what? Expecting an acknowledgement. So the acknowledgement number here will be what? The number of the next expected byte. Next expected byte. So in this example, we have the maximum message or segment size. Maximum segment size is set to 1040. 460 bytes. We'll talk about it in the next slide. Now let us focus on the window size. During the three-way handshake, A and B or B as a receiver identify or initiate the window size to 10,000 bytes. What does that mean? That A can start sending from byte 1, first byte, and the last byte can be sent from A without receiving any acknowledgement is the bytes number 10,000. One more time. We have set the window size to 10,000, which means host A as a transmitter can transmit the first 10,000 bytes without receiving any acknowledgement. Without receiving any acknowledgement. What we call this? The send window at the sender, at BCA. So the window size includes also every TCP segments so that destination can modify the window size, by the way, at any time. Now, let us apply the example. Now, we have set the window size to 10,000. Now, host A send the sequence of the first 1,460 bytes. So from 1 to 1,460 received by B. Then continue. This is the maximum segment size, 140 bytes. Next sequence or next bytes from 1,461 to 2,920. Now, PCB did not wait or should not wait until it should receive 10,000 bytes. No need to wait for this long of time. So in this case, as shown in the figure, when BCA will send an acknowledgement. Sorry, B is acknowledged the first 1,460 bytes. Now, what's the acknowledgement number? So PCB receives the byte from 1 to 2,920 by using two separate maximum segment size. Now PCB acknowledge the received segments. How it will acknowledge? Sending expected byte. What's the next expected byte after 2,920? 2,921. PC now B performed A or informed A, we will continue using the window size 10,000. So as shown here, when BCA receives the acknowledgement with acknowledgement number 2,921, it means that next byte expected by BC1 to be sent is the byte 2,921. So the BCA here window will be incremented by 2,920. This changes the send window from 10,000 byte to 12,920. So first 2,920 byte receives correctly. So we'll increment the send window size by this amount. But It doesn't mean that now the window size become 12,920 bytes. It's still 10,000 maximum number of bytes to be transmitted before we expecting the acknowledgement is 10,000. Now, host A send the next 1,460 bytes from 21 to 380. Now, BCB acknowledge this, so the acknowledgement number will be 4,381. So the window size now will be incremented, the send window size will be incremented what to be 14,380 according to the last received. But we still using what? 10,000 window size. So we can send up to 24,380 before we expecting an acknowledgement from BCB. But keep in your mind, the receiver do not has or have to be wait until the last byte of the window size is received. It can be acknowledged any received byte. Once it's acknowledged, send window size, send window will be incremented by the number of the acknowledged what bytes received. But the window size is still the same. 10,000 bytes, I'm expecting acknowledgement. 10,000 bytes, I'm expecting acknowledgement. Now, what about the message or the maximum segment size? Maximum segment size provide a mechanism for control the flow. Maximum segment size is the maximum amount of data that the destination device can receive. Now, window size, maximum amount of bytes we can receive before we send an acknowledgement. MSS, maximum amount of data the destination device can receive. So I will send 10,000, but at each time the maximum amount 1,460. Now, a common MMS is 1,460 bytes when using IPv4. How? Simply, the host will determine the value of the MMS field by subtracting the IP and the TCP header from the Ethernet maximum transmission unit. Usually, the Ethernet maximum transmission unit is 1,500 bytes. Now, IP and TCP headers 20, so we'll subtract 40 for the IP and for the TCP, so 1,460 bytes left for the maximum segment size. Now, when congestion happens, how we can avoid it? When congestion occurs in network, it results either packets being discarded or by the overloaded router or lost in somehow, or we will lose some packets. So when packets containing TCP segments do not reach the destination and they are left without acknowledgement. So what we will do in this case? Simply, sender can determining the rate at which TCP segments are sent but not acknowledged. So the sender can estimate how many segments sent. After that, I did not receive an acknowledgement. So the source here can assume the level of the network congestion. So the source can reduce the transmission rate. As you see here, source A, for example, send the first 4 segments. But it receives an acknowledgement that I have received 1, I expecting 2. So source A now reduce the transmission rate from 4 segments to 2 segments as an example. So what we will do in this case, we are avoiding the congestion, avoiding losing the segments. To avoid and control the congestion, TCP employs several congestion handling mechanisms, timers and algorithms. For the UDP to be fast, we still have one more session or one more module. UDP do not establish a connection. UDP provide lower overhead data transport because it has a small datagram header, only 4 fields, and no network management traffic. Now, when we talk about the UDP, keep in your mind UDP does not track the sequence number the way TCP does. UDP has no way to reorder the datagram into their transmission order. So as you see, we have sent the datagram from 1 to 6. We have lost 3 and 4. Or assemble it on the same order it arrived. We do not have a reorder option. So we have it received as the order 1, 2, 6, 5, 4. So UDP simply reassembles the data in the order it was arrived to the application. So there is no reordering. First datagram received, it will be the first one. Second one, second one. Third one, third one, regardless of the actual order or the original order. Now, UDP, as we have mentioned, used for the server-based request. So UDP-based server application are assigned a well-known or registered port number. We have a DNS server, and this server considers also for the radius, the authentication and authorization services. So UDP will send the request by using well-known port number assigned port 53. Radius was registered remote authentication dial-in user services. Server registered by Cisco, it will be used the port 1812, 1812. So the client will send the request to the server and it will be received on this port. DNS request to the server will be received in port 53. So the UDP receives the datagram destined for one of these ports. It forwards the application data to the appropriate application based on the port number. So the client, in this case, dynamically select a port number from the range of the ports and use this as a source port for the conversation. So, client would like to communicate with the server for the DNS request. The client will generate a random port number. It will be used as a source port to send the request to the server. So the source port here, is the client generated one. The destination port will be the port of the server, 52. Now when the server replies back to the client, the source will be the port number of the DNS, 53. The destination will be what? The port at the client side, 49152. So destination port is usually well known, while the source port is generated randomly from the available range. After the client has selected the source and the destination port, the same pair of the ports are used in the header for all datagram in the transaction. So, session created, source port identified, destination port identified, source and destination will be used to exchange or transfer the datagrams. Now this is the end of session or module 14. We need to start with module 15. As you see, it's a little bit memorizing part. But what about 15? Let me say it's totally memorizing in somehow. So let us carry on. Right. Now, what we will talk about in module 15, the last layering, the application layer. So simply, the upper three layers of the OSI module, as you see, application and presentation and session layer, defines the function of the application layer of the TCP/IP module. Now, the application layer provides an interface between the application used to communicate and the underlying network over which the messages are transmitted. So, as you see here now, we have an application layer. Many application layers can be used: domain name, hypertext transfer protocol, simple mail transfer protocol, post office protocol, dynamic host configuration protocol, file transfer protocol, internet message access protocol. So this is the most widely known application layer protocols can be used at the application layer. Now, so let us talk about the three layers of the OSI module. Presentation layer has a three primary functions. First step, formatting or representing the data at the source device into compatible format for the received by the destination device. So data formatting. Compressing data in the way that can be decompressed back at the destination device, encrypting data for a transmission, and decrypting data upon receipt. As you see, presentation layer format the data for the application layer and set the standard of the file format. Some of the well-known now standard format, for example, for the video, we have Metroska video, MKV. We have motion picture expert group, MPG. We have a QuickTime video, MOV. Some well-known now image formats. We have the graphic interchange format, joint photographic expert group, or joint photographic, expert group, JPG. We have portable network graphics, PNG. Some email format or protocol, SMTP, BOP, IMAP, Internet Message Access Protocol, and so on. We have file transfer protocol, TFTP protocol. We'll talk about it as well. Here we are talking about a standard file format. Now, session layer. So we have application, presentation, session. Session layer, it creates and maintains the dialogue between the source and the destination application. Session. It handles the exchange of information to initiate the dialogue, keep the dialogue active or the session active, and restart the session that are disrupted or idle for the long period of time. Application, presentation, session, according to the OSI module, represented by only one layer called application for the TCP/IP module. So the TCP/IP application protocol specify the format and control information necessarily for many common internet communication functions. Application layer protocol used by both the source and the destination device during the session. For the communication to be successful, the application layer protocol that are implemented on the source and the destination must be compatible. Example about some application layer protocol: DNS, DNS, it can be a TCP or UDP. TCP between servers, UDP client and server. What's the port number? 53. Why we need it? To translate the domain name into IPv4 or IPv6 address. DHCP, Dynamic Host Configuration Protocol. A UDP at the client will be a port 68, at the server 67. It will be used to dynamically assign an IP address. When the device is activated, the device needs information about the network, so it will be obtained from the HTTP server. Web Hypertext Transfer Protocol, a TCP used the port 80. So it's a set of rules exchanging the text, graphic images, sound, video, and other multimedia files on the World Wide Web. We have the mail protocols to send an email, SMTP. It is a TCP, will use port 25. To retrieve an email from the email server, Post Office Protocol, POP3. It will use a TCP port 110. Internet Message Access Protocol to get a copy from the email server, not retrieve it and delete it from the server. It will be used TCP port 143. We have File Transfer Protocol. We have Trivial File Transfer Protocol and many other protocols. Now, what's the peer-to-peer client-server module? And it was covered in Module 1, by the way. Client and server processes are considered to be in the application layer. In the client-server module, the device that requesting the information is called the client, and the device that responding to the request is called a server. So application layer protocol will describe the format of the request and responses between the client and the server. So client, the device request a service, server, client send the response back to the client. Now, application layer responsibility is to what? Describe the request and the response format between the client and the server. One example, for example, we can have a client. The client will send the request to the email service of the ISPs. So the client will send the request to the email. Kindly, I would like to check if there is any new email received to me. Server will send back a response to the client about any unread email. So the request and the response should be formatted between the client and the server in this case. Now, what about the peer-to-peer? Peer-to-peer network means we have two or more computers connected via network and can share resources such as a printer or file without dedicated server. Keep in your mind, in peer-to-peer network, the same device can act as a client and can act as a server at the same time as well. So every connected end device called peer and can function as server or as a client. Example, we have a peer-to-peer connection between peer 1 and peer 2. Now, peer 1 has some data required by peer 2, so it's the file server now here. It can act as a client and file server. Now, we have a directly connected printer to PC2. So, PC1 can request to access the service, the printing service, through peer 2. So, to peer 2 here is what? It's a server. So, when I request the FTP, I'm a client. When I provide the printer services, I'm a server. So, on peer-to-peer, devices can act as a client and a server at the same time. Also, some peer-to-peer application uses a hybrid system where resource sharing is decentralized, the resources is decentralized, but the index of that resources is stored in centralized location or directly. So in the hybrid system, each peer will access the index server in order to get the actual location of the resources stored in other peer. So one computer might assume the role of the server, another computer assume the role of the client. Now, peer-to-peer, as we have mentioned, can act as a client and a server. Some application uses a hybrid system, means we have multiple resources in different devices or location, but we'll have an index about these resources in centralized location. As a device, I will access the index in order to know where I can find that requested resources. Now, with peer-to-peer application, also each computer in the network that is running the application can act as a client and a server for the other computer in the network that are also running an application. In general, the common peer-to-peer network application including the BitTorrent, Direct Connect, eDonkey, Freenet, and there is many other applications. For example, some peer-to-peer application based on Nutella protocol. Now, what is this? Each user will share a whole file with other users. So in this case, okay, client software will allow the users to connect to the provider or the device that containing the whole file, so it can be shared through the internet with multiple devices. As an example about peer-to-peer application. Now let's talk about quickly and the email protocol. For the web, we will use the HTTP. We can use the HTTPS. What's the difference between them? HTTPS is secure protocol, encrypted protocol. Will use either the transport layer security or the secure socket layer for encrypting the data stream. Now, when the web browser or when the web address, a web address or URL, as we can call it, Uniform Resource Locator, is typed in the browser, what will happen? The web browser will establish a connection to the web server. The web service here is running on a server that is using HTTP protocol TCP port number 80. So to understand how the web browser and the web server interact, let us take an example. Suppose you open your browser, you type cisco.com/index.html. So step number 1, the browser will interpret the address into 3 parts. Which address I'm talking about? The URL, the Uniform Resource Locator. A protocol, HTTP, the domain name or the service name, www.cisco.com. Finally, the specific file requested. What's the file I'm requesting? From cisco.com, index.html. Now, step 2, browser will check with a name server to convert the name into IP address. So it's a DNS process. We need to convert cisco.com to the actual IP address of this one, which is used to connect to the server. Now, once the name is translated, the client will initiate HTTP request by sending a GET request to the server and ask the server about index.html. Next step, number 3, in the response to the request, to the GET request, the server send HTML code to the web page to the browser. So the browser will send the GET, kindly provide me with a page index.html. Now the server will respond back by sending the HTML code of that web page. Finally, step 4, my local browser as the client will decipher the HTML code and reformat it or represent it as a web page on my browser window. So, HTTP quickly, we need the URL. URL will be mapped to an IP address. Once we map it, we will send the request to the server by sending a GET. Web server send the data code or the HTML code of that page. HTML code will be decoded or deciphered to get the web page at the client website. So what's the difference between HTTP and HTTPS? HTTP Hypertext Transfer Protocol, request and response exchange between the client and the server will be without any encryption. So it sent or exchanged the, let me say, data in the plain text format. Now HTTPS, it's a hypertext transfer protocol, secure, which means it uses authentication and encryption processes to secure the data as it's travel between the client and the server. So usually HTTPS will use the same client request server response process, but the data will be encrypted by using the TLS, transport layer security, or by using the SSL, secure socket layer, when the data exchange across the network. So HTTPS secure encrypted session, HTTP a plain text and secure session. In general, a 3 common message type: send, get, post, and bot. Get is a client request for the data. So the client web browser will send the GET message to the web server requesting any HTML page. Post, it's upload request. So upload data file to the web server, for example, as a form data. Bot now uploads resources or content on the web server, such as an image. So either we the resources or uploads a data. Now for the email, simply we need to send an email and we need to receive an email. Email protocols are the following: simple mail transfer protocol to send an email, post office protocol, POP3, and IMAP message access protocol to receive what? The emails. Now, when the client sends an email, the client SMTP process connect to the server by using a TCP on port 25. So this is the SMTP protocol. After the connection is made or established, the client will attempt to send an email to the server across that connection. When the server receives the message from the client, it can place it directly in the local account if the receiver is located locally at that email server, or it can be forwarded to another email server, where the other email server either can locate it or save it locally to the receiver or resend it to another email server until it reaches the destination server. So the destination email server may not be online or it can be busy. So simply the SMTP will spools the messages to be sent at later time. So how we will send an email? Establish a connection with a server by using SMTP on port 25. Then we will send a request. We will send our email to the server. The server will handle the delivery process. Which server? I'm talking about the email server. Now, what about the POP protocol? POP is used by an application to retrieve emails from the server. When the email is downloaded from the server to the client by using the POP, the original email will be deleted from the server. This is the main difference between POP, Post Office Protocol, and IMAP. Now, Post Office Protocol, the client will download the email, the incoming email, locally. So it will be deleted from the server. If we are using IMAP, Internet Message Protocols, like Google or Yahoo or Hotmail, now you will what? Download a copy of that email to your client, but you will keep the message stored at the server. It will not be deleted. So this is the main difference between POP and IMAP. POP, download the email from the server, it will be deleted on the server. So the server starts the POP service by passively listening on the TCP port 110 for the client connection. When the client wants to make or to use the service, it will send a request to establish a TCP connection with the server. SMTP POP IMAP started with TCP establishment session. When the connection is established, the POP server will send a greeting message. Now the client and the POP server then exchange a comments and responses until the connection is closed or aborted. So TCP session, greeting messages, exchange, comment. The client will receive the data of the emails. The connection then can be terminated or closed. IMAP, following the same procedure, same standard with the server, except of that, IMAP will save a copy of the message on the client application, but the original message will be kept on the server until it's manually deleted. While POP, we download the message, it will be automatically deleted from the server after we download it at the client. So when the user decides to delete the message, the server synchronizes that action and delete the message from the server. Now for the domain name services, domain name were created to convert the numeric IP addresses to a simple recognizable name. For the fully qualified domain name, simply the DNS will convert cisco.com to the actual IP address. DNS protocols define an automated services that matches the resource name with the required numeric network address. It includes the format of a query, responses, and data. So the client will send a query to the DNS server. I need the address of cisco.com. DNS server will map the name into IP address, send the response to the client. The client will communicate now with the server by using what? The actual IP address resolved from the DNS server. DNS server stores different type of resources, records that are all used to resolve the name. DNS server different type of records or resources that are used to resolve names. These records contain the name, address, and the type of records. In other way, DNS will obtain different records for different group of addresses
or for different type of addresses. Some of the records type A, which means an in-device IPv4 address, and as authoritative name server types or records. Quad A, an in-device IPv6 address. MX records, mail exchange record. When the client make a query, the DNS process first will look to its own records to resolve the name. If it's unable to reserve or to resolve the name using by its locally stored records, it will contact another DNS server to resolve the name. After the matching is found and returned to the original requesting DNS server, the server will temporarily store the number address in the event that the same address is requested again. So, simply, I am a DNS. I have received a request. Give me the IP address for this name. Now, the DNS server, as a first step, will check the locally records. If we find a match, we'll send a response and the process is completed. If we do not resolve the name to an address, we'll send a request to another DNS server. DNS server will search. Find, it will send a response. Do not, will ask another DNS server, and so on. Now, when the original DNS receives the matching, the IP address, it will store the address for any future use in temporary memory. So if the client requests one more time the same domain, the address can be provided immediately. Now, DNS uses the same message format between the servers, consisting a question, answer, authority, and some additional information for all types of client queries and server responses, error messages, and the transfer of resource records. So, DNS message question, usually the question for the server name, answer, resource records answering the question, authority, resource records pointing toward authority, any additional information holding any additional information about the records or any additional data. Now, I'm a little bit faster because it's simply a memorizing. Now, DNS also divided into a set of levels. At the top level for any domain name, we have the root level domain. Now, at the top level or below the root level domain, we have a level called top level domains. At the top level domains, we have divided the domains according to their category. We have .net, network, .edu, educational, .com, commercial, AU, for example, Australia as a country, .co, cooperation, and many other top-level domain levels. Now, any top-level domain will be divided to a second domain level and so on. So at the second domain level under the com, we have cisco.com. Cisco.com redivided into .com, ftp.cisco.com, mail.cisco.com. So DNS uses hierarchical system to create a database to provide a name resolution. Each DNS server maintains a specific database file and is only responsible for managing name to IP mapping for a small portion of the entire DNS structure. When the DNS server receives a request for the name translation that is not within its DNS zone, the DNS server forwards the request to another zone, so the DNS server within the proper zone will translate that name. Example for the top level names, we have com, org, organization, we have edu, AU for the country, Australia. What we have also .gov, a government, many other top-level domain names. Why we divide it into top-level domain names? Simply to simplify or speed up the name to IP resolving a process. Finally, we can use the NS lookup on the computer operating system as an utility to manually query the DNS server configured on the device name. Simply NS lookup followed by the domain name. So we can write NS lookup space cisco.com. What you will do, you are sending a request to your local DNS. Your local DNS will map cisco.com to an actual IP. The IP will be sent back to the client. So this utility usually used to troubleshoot the name resolution issue and verify what the current status of the name server. Now I will write NS lookup. So we have entered the configuration of the NS lookup, google.com, cisco.com. I did not receive any response from the DNS server. So we have DNS problem. It helps us for troubleshooting. So when the NS lookup command is issued, the default DNS server configuration of your host is displayed. NS lookup, we have the default DNS configuration. The name of the host or the domain then can be entered at the NS lookup prompt. You can try this. Simply, we are sending a manual request to the server. We are checking the DNS server resolving IP address. So you can type, for example, NS lookup space www.google.com. Once you click enter, it will be sent to the DNS of your ISP's provider, the DNS server. DNS server will send back to you what the IP address of google.com. I will stop here since we already exceeds 2 hours.